Okay, Assalamualaikum and hello. So I already checked your assignment one. Actually, all of you don't get the answer actually. So many of you get almost thousand and 100,000 ringgit. Okay, so which is very wrong. Okay, you can see here this is the assignment here. So you can see here the average payment for this company is actually only 670 ringgit. But you get almost million ringgit, so means that your answer is totally wrong. So right now I give the answer, the mark is quite low. Okay, not quite low, but 3/5. Okay, but if you want to improve your mark, okay, to 5%, okay, you have to you can try to improve the assignment and submit it before the next week. Okay, try to do this before next week. So you can see here this is the given data. Okay, so this is the given data. You can see here data start from 6 a.m. okay, 6 a.m. in the morning and until, okay, if you look here, 5:59 the next day. Okay, so the data is, you can see here, for every minute. So that is the keyword, every minute. Okay, when it comes to every minute, you have to make sure that the unit is correct. Okay, so you have the voltage here. Okay, you have the current here, and you already have the power Q and P and Q. So what you have to do is you have to find the energy. Okay, how to find the energy? Of course, you can look here. So energy, so this one is in watt. So usually energy is kilowatt hour. Okay, when it comes to TNB, they use kilowatt hour. So how you can see it? So if you look at the website, you see here kilowatt hour. So make sure you have to convert in kilowatt hour by dividing to 1000, and of course this data for every minute. So means that because this data, the power is every minute, you have to divide by 60. Okay, so make sure you divide by 60 because it is only for 1 minute. Okay, for 1 hour, of course this is the same. So for example, this is the power P. For 1 hour, if power is 55.0 or 55, okay, power is 55. Okay, if you change it to energy, it is 55 kilowatt hour. But that is for 1 hour. But this one is only 1 minute, so you have to divide by 60. You get this answer for A, B, C, and of course you have to find the Q also. Okay, you have to find the Q. Okay, Q is, you just use the same formula. Okay, divide by 1000, divide by 60. Okay, because we use kvar. Okay, kilowatt hour. Okay, so you already have that. Okay, and you have to total up A, B, C because usually TNB will just sum up your power, energy consumption. So you have the energy consumption for every minute. Okay, so this one is just sum it up. Okay, and then from this you can calculate the power factor for every minute. So power factor, of course, P divided by S, or P equals to square root of P squared plus Q squared. So if you recall, you have many ways to calculate this actually. If you learn in the class, P divided by VI, right? So depend on you. Okay, you have multiple ways to calculate it, but usually it end up the same. And another thing that you have to look when it comes to power factor, you have to know whether there is lead or lag. For me, for lead, I just sum it as positive, and it is less than 0, the Q, okay, the Q is less than 0, means that it is lagging. So I just put negative. So I just run it up. Okay, if leading is positive, lagging is negative, something like that. Okay, so after that I just multiply this. Okay, so just to ensure that you can determine whether the power factor is leading and lagging, because you want to do power factor correction, leading and lagging is very important. Okay, it can be very different thing. So make sure you know how to do this. Of course, this one is just multiply. Okay, if lagging means that it's positive, if leading it is negative. Okay, so that is how you analyze the data for one day only. So one day, why we want to know? Because of the load profile. Remember chapter 3.1, 3.3, okay, load profile. Okay, that one will be in your final exam. Make sure this one, try to understand. The question is less complex than this. This one is much more complex. So you can see here the result. You have to plot the result, the load profile. You can see here the total P, okay, energy consumption. You can see here the P is the blue one, the Q is the orange, I think. Okay, orange. So you have to plot this. You have to show where the power goes. Okay, you can see here at 8:30 to 21. 21 is 9 p.m. Okay, the power very high. Okay, so based on this, you have to show this. Okay, you have to show this, and you have to show the instantaneous power before compensation. Okay, you can see here power factor is very low. Okay, during non-working hour. So this is non-working hour. So this is working hour. You can see here it's changing, but you can see here the value is all positive. So remember I said when it's positive it is lagging. So make sure you assign it. Just in real time, in reality, there is no positive negative power factor. But for the sake of this assignment, it is better for you to assign it. Okay, so easy to see. Okay, and then you have to calculate the daily. Okay, you have to sum up the total. Okay, you already done the total energy. Okay, the PT ABC and QT ABC. Sum it up, you get something like this, 44 per day. Okay, this one is the real answer. Your answer should be the same. And then for monthly, you have to multiply by 30. Okay, remember TNB bill is 30 day. So you have to multiply by 30. This is data is only for one day. Okay, so before the composition, of course, you have to calculate the bill. I give you the link, right? So you have to look at the link. Okay, this is the link. So power factor surcharge, you have to look here. Okay, this is the power factor surcharge. Okay, so 1.5% for every this one, okay, and this one. And also the tariff, of course, you have to go to commercial. Okay, you can see here tariff. Okay, click tariff, and this is industry tariff. Okay, why? Because you can see here this is where is it? Okay, factory is industry, and it is very low voltage. Okay, 415. Okay, it is a low voltage. So most of you, okay, I think all of you don't show the tariff you use. So this is the tariff, industrial low voltage tariff. Okay, so based on the characteristic, you have to know which tariff you have to use. Okay, what is medium voltage? You can check it out. What is medium voltage? What is this one? Different time, different way. So you have to know this, because this is actually in your chapter 3.3. Okay, so you need to know how to calculate this. Okay, so you can see here the first 200 kilowatt hour you have this rate, but after that you have to pay this rate. Okay, so you have to calculate it, of course. If less than 200, okay, you only look at the PT, the energy, the real energy, active energy. Reactive power you don't look. This one is for the surcharge. Okay, you can see here if less than 200 is you just multiply it, but if it is more than 200, you have to pay the 200 first and then multiply with the new tariff. Okay, the second tariff, this one. Okay, this one is I already teach you in your chapter 3.3. Okay, just use it. So you get the bill, but because this is industry, you have to pay surcharge. If you are residential, you don't need to pay the surcharge. But if you are industry, you have to pay surcharge. So surcharge is basically you look at the power factor. So monthly power factor, you have to calculate the monthly power factor. So basically you have to look at the month, not the day. Okay, you have to look at the month. Okay, so after you look at the month, here is the month. You just use the formula P divided by S, or P divided by square root of P squared plus Q squared. Okay, you can get the power factor. So you get the power factor. The average power factor for monthly is 0.634. That is how you get the average power factor for 1 month. So how to calculate the surcharge? Of course, this one. Okay, so if your total power factor, let me show you the website here. So if your power factor is between 0.75 to 0.85, you only have this rate. But if you less than 0.75, you have to pay for this rate and as well as this rate. Okay, this is way to calculate this. Okay, they give the example how to calculate. Okay, try to understand this. Okay, kilowatt, K, VAR, and so on. Okay, make sure you understand this. Okay, and then after that you get the surcharge, the penalty. Okay, in I think in your notes it's called penalty, right? So this one is actually you have to sum this up. You have to pay the bill, the energy, real energy that you use, the blue one. Yeah, this is the blue one. And also you have to pay the surcharge, the reactive energy. So the orange one, you have to pay it also because you don't take care of your power quality. It is very bad. Okay, so because of the surcharge, your electrical bill increased almost 50%. Okay, so your task is to do this one. You have to do the install capacitor, which is power factor correction. So this is very common. Okay, so you have to calculate. So the compensation plan, you have multiple compensation plan. Okay, you don't expect only one. Okay, previous student provide multiple way to do this. Okay, but this is the simple one. I can show you, easily understand. So basically, when you look at the profile, load profile, you can see here 8:30 to 21. Okay, 9 p.m. 8:30 p.m. to 9:30 p.m. Okay, the Q is very high, so you want to compensate this. Okay, you don't want this because this is affecting your power factor. So you have to compensate that Q. Okay, during that time only. Okay, this one no need because this Q is quite small. Okay, so you have to outside, and then you have to disconnect the Q. Okay, remember, if your Q is still connected here, okay, the power factor will also drop. So you only have to connect the Q, okay, the capacitor during this time. If you still connect it, it will produce negative power, and negative power also consider very bad power factor. Okay, even negative, positive and negative is bad. So that's why you have to disconnect at this location. So that is your compensated plan. So the average, you have to calculate the average here. So you can see here, I don't look at all the data. Okay, so I only look at the data that has Q high. So you can see here, I highlight it. The higher the Q, the yellow and red it is. So the green one I don't consider because it is very small, but it is very high, you have to consider it. So I calculate the average for this one, for the yellow and red one, for Q, not P. You compensate Q, not P. Okay, so after that I get this one. Okay, Q is in negative. Okay, this one should be positive. Okay, positive, but so you have to compensate, you have to put negative. Okay, the average is 39955. Okay, and this one you have to convert back. Okay, convert back to VAR. Okay, you want to do compensation, you cannot use the energy, you have to use the kVAR. Okay, so the voltage, of course, you have to record the average voltage for that time only. Remember, voltage depend on Q. Okay, if the Q is more negative, okay, higher towards negative, the voltage increase. Higher toward positive, the voltage reduce. So you have to know the voltage, every voltage here. because you want to design the compensator, C compensator, and then you can get this. Okay, so you can see here only at that time. Okay, and then the frequency, and of course the compensator, you have to use the formula Q compensate divide by what? Q compensate divided by V squared divided by 2 pi F. Okay, so you already have the capacitor. It's actually 0. Let me, okay, cannot okay, it's okay. Just okay, 203 microfarad. So basically you have to put 203 microfarad capacitor for each phase. Okay, so you have to do that. Okay, oh, this one is total phase, so for each phase you have to divide by 3 lah, because this Q is for all. Okay, so C compensator each phase. Okay, each phase you have to divide by 3. Okay, so you get 67. Okay, so this is for each phases. Okay, right now my analysis is not very great because I just add everything up. Actually you have to analyze each phase. It is much more better if you can analyze each phase. Okay, so after compensate you have to show it. Okay, this is before the compensate. Okay, and how about after compensate? You have to calculate back. Okay, P is actually the same. When you do compensation, power, real power is the same, but reactive power you have to add the new value. Okay, so this is the original value and you have to add. Okay, you have to add the, what you call, the new compensate value, this one, the compensate, the expected to compensate. Okay, and you have to add it at certain time only. For me, when the W is more than 0.015 kVAR hour. Okay, okay, when it's less than that you just leave it out. Okay, no need to put the capacitor. But after this one, after if the value is larger than 0.015, the QT, okay, you have to connect the power connect the capacitor, and means that you have to include this one, and make sure this is in VAR. You have to convert it to kVAR hour. So divide by 60, divide by 1000. Okay, unit is very important. So after, you can see here, okay, add it up. Okay, you have add it up and calculate the power factor, of course you know, and you have to determine leading or lagging. Okay, this one is the multiplication of the leading, lagging. Okay, I remind you again, power factor don't have negative. This is just to represent the leading and lagging. Okay, it is not official. Okay, so you can see here. Okay, this is the tarif. Okay, before. So you have to show the result after compensation. So you can see here, this is after compensation. So you can see P remain the same, the blue one remain the same. But for the Q, you can see here it reduced tremendously. Okay, you can reduce it a lot after the compensation. The power is just gone. So you can see here the new power. Okay, you can see here the total per day, the total per is quite reduced. Okay, the original one is 1.6. Okay, but the total now is just 100. Very high reduction because of the capacitor only. And this one is bill is the same. Okay, bill always the same if the load is the same, but the surcharge you can see here is 0. Okay, the average power factor is 0.99. Previously the power factor is 0.6 is bad. 1 is good, 0 is bad. So 0.99. Okay, so no surcharge. You don't have to pay 300 ringgit. Okay, surcharge. So the bill you can save 50%. Okay, that's why you do power factor compensation, because you can reduce the bill a lot. And you can see here the power factor is near to 1 almost all the time, except during this time. Okay, so this one 0.5 during the non-working hour, but it is actually quite small, so no need to consider. You want to compensate it is quite complicated, but depend on you. If you want to do the complicated one, it's okay. But during this hour, which the power is quite high, you can see here the power factor is almost near to 1. So this is improve. Okay, so that is the result that you have to show. Okay, the bill. Okay, the bill, of course you have to show the change. Okay, this one. Okay, you have to show the load profile. It is better if you can show the 3 phases. Okay, so this one, I see that in your report you don't have everything here. Actually your report I should give only 1 actually, but I give you 3, okay, to help you, but I cannot give you 5. Okay, if you want to get 5, try to finish up this report. Okay, you have to show something like this before the next weeks. Okay, this week I need to okay, try to submit this week or next week before the end of the week, because I have to key in your mark. Okay, so try to, if you want to improve your mark, okay, I try to do this. You have to show everything here. Okay, so that's it. Okay, good luck. If you want to do correction, make sure you tell me whether you want to do correction or not. If you don't want to do correction, if you don't tell anything at me, I assume you don't want to do the correction. Okay, so that's it. Okay, thank you.